Question 10. A drunk driving offence is committed if the blood alcohol level of a driver is over 80 milligrams of ethanol per that much of blood. Was a concentration? So we can find out the moles. Mass in grams. Well, 80 milligrams in grams we divide by 1000. 123 divided by the MR of ethanol, 46. And then obviously we're trying to find concentration, moles of concentration and volume. Concentration is going to be a number of moles divided by the total volume. 100 centimeters cubed, but we want a moles per diem minus cubic centimeter, divide that by 1000, 0.100. Should get 0.017. Question 11. Which statement is correct for the distribution curve of molecular energies in a gas? So, number 1, the curve is symmetrical about the maximum. It's definitely not symmetrical about the maximum. There are always some molecules with zero energy. One of the key facts of Maxwell-Boltzmann curve, and they like to test this, is that the idea there are no molecules. There are no molecules with zero energy. So just by that fact alone, B is incorrect. The position of maximum curve is not dependent on temperature. That's false. It is dependent. It is dependent on the temperature, because that's the whole point of the distribution curve, to show how the molecules change with the temperature increase as well. Because you know you have your normal curve, and then if you increase that temperature 1, increase temperature 2, obviously that's not a great graph, but the peak becomes lower and it shifts more to the right. So the position is dependent on temperature, therefore the answer is D. The mean energy is greater than the most probable energy of the molecules. And that's true, because if you draw it out, most probable energy is something here. The mean energy is just a bit to the right of the most probable energy, so it would be greater. Question 12. 1 mole of ammonia is heated to given temperature. 50% of it dissociates, so we're left with 0.50. Following equilibrium is established. So this is before the equilibrium. So before the equilibrium is established, we've only got now 0.50 moles of ammonia. What's the total amount of moles in gas and equilibrium mixture? So 0.50, half of that, 0.25, and then times that by 3, 0.75. Just using the molar ratios, we add that all up, we get 0.75 plus 0.75, which is equal to 1.50. So for the answer is A, 1.5. Which compound is not an isomer of the following compounds? First things first, let's add on the hydrogens. And you know, for these specific types of questions, there's specific methods that you have to use to attack it. So how many carbons do it have? C1, 2, 3, 4. C4, H, because yeah, 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6, 7, 8. C4H8O. And if you don't know the carbons, but we can realize all of them have the same number of carbons for the compound, so it must be C4H8O. So if we write this out in this format, that's also going to be C4H8O. In this case, it's going to be C1, 2, 3, 4, C4H 3, 4, 5, 6, 7, 8O. In this case, it's going to be C1, 2, 3, 4, all of them are C4s. H6, 6, 7, 8, H8, O. And in this case, it's C1, 2, 3, 4, H1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, O. So you can clearly see that is not the same as the rest of them, and in order to be isomer, it's the same. It's the same formula, it's just a different rearrangement. So all of these have the same as this. So all of these are isomers of the following compound. This one, 2 less hydrogen. This is not an isomer of the following compound. Question 14. How many isomers are there of this? You just draw them all out and you should get C. 4 isomers. Which equation represents the propagation step? That is a termination. We've got initiation, propagation, termination. That's a termination. That's a termination. That is initiation. I'm probably spelling these wrong, but it doesn't matter really. And D, that is definitely a propagation. Just how well you know the steps, and therefore the answer is D. Which compound can react with ammonia to form propylamine? Now this is an example of what? Ammonia to produce propylamine. It's nucleophilic substitution. Nucleophilic substitution. And now with nucleophilic substitution, react with ammonia to produce propylamine. And for this, it needs to be a halogene alkane. The compound needs to be a halogene alkane. Definitely not an alkene, not an alcohol. The answer is C, because that is a halogene alkane. Whereas D, that's just an alkane. There's no halogen attached to it. And if you look at the mechanism, ethane, propane, CH3, CH2, CH2Br. Got ammonia, NH3, lone pair of electrons. This is not, I'm just going to do a quick version of it. Tax carbon, positive, negative, there, and we're left with this. Lone pair of electrons, NH3, takes a proton there, and then you form propylamine. Question 17, which statement is not correct about this? C double bond C, CH2, CH3, CH2Br. It displays EZ isomerism. That is false. If it display EZ isomerism, could be chiral carbon. We've got to have each carbon has to have 2 different functional groups. These 2 are the same. Forms a addition polymer, yeah. It reacts with electrophiles, yeah. Alkenes react with electrophiles, electrophilic addition. Equal as bromine water, obviously, because of carbon-carbon bond. And the answer is A. Which compound can be oxidized to form this? So, what is this? This is a ketone. And which compound can be oxidized from this? Secondary alcohols. Oxidize them and will form a ketone. So if you look at 2-methylpropane 1-O, methane, ethane, propane. Alcohol group is on the first carbon. We've got a methyl, second carbon. H, fill in the hydrogens. That's a primary alcohol. So that would be oxidized to form an aldehyde, actually, not a ketone. So it's not A. B, 2,2-dimethyl propanol, methane, ethane, propane. You've got 2 methyl groups on a second carbon. Fill in the hydrogens. And we've got 2,2-dimethyl propanol. So I'm guessing the OH group is just on the first carbon. Wherever it is, it's still a primary alcohol. 2-dimethylbutane 2-ol, methane, ethane, propane, butane, 2-methyl. So there's an alcohol group in the second carbon. There's also a methyl group in the second carbon. And then you fill in the hydrogens. Look what we have. We've got primary, secondary, tertiary alcohol. So it definitely can't be this, because if it's tertiary alcohol, we can't oxidize tertiary alcohol from ketone. And then if you look at D, 3-methylbutane 2-ol, we just draw it here: methane, ethane, propane, butane, CH3-methylbutane 2-ol, alcohol groups here. Fill in the hydrogens. And what do you notice about this one compared to the rest of the structures? This one is a secondary alcohol. This one's a primary, A was primary, B was a primary, C was tertiary, and D is a secondary alcohol. And secondary alcohols can be oxidized to form a ketone. Therefore, the answer is D. The reason I went in this to detail is because they really like to ask these type of questions. Which compounds oxidize from this? You have to do the reverse of it in some cases. So yeah, it's a ketone, secondary alcohol. Therefore, the answer is D. Which species can act as a nucleophile? Nucleophile definition: electron pair donor. That's all you really need to know. Electron pair donor, like for you to understand it. So in this case, NH4+, well, that's just an ammonium ion. You know, it's got no lone pairs of electron, and a square bracket, and it's got positive charge, iron. Same with CH4. Carbon can only have 4 bonds, so that's it. And H+, well, it's just a H+. So the answer must be B. Yeah, CH3OH. Which alcohol forms a mixture of alkenes when dehydrated? A mixture of alkenes when dehydrated. Obviously, dehydrated form alkenes from alcohol. Propan-1-ol. Definitely not going to be propanol or propan 2-ol, because they're just going to form, in this case, alkene. The first carbon, in this case, the second carbon. Not going to form a mixture of alkenes. So it's either between pentan 1-ol and pentan 2-ol. The answer is going to be pentan 2-ol. Question 21. Which compound has the highest boiling point? Again, when it talks about highest boiling point, you usually just need to look out for hydrogen bonds. We don't look at the MR. 9 times out of 10, it's looking for hydrogen bonds. Look for hydrogen bonds, right? A definitely does not have hydrogen bonds. B does not have hydrogen bonds. So it's either between C or D. And C, well, if we draw out C, CH3, some cases you need to draw them out to see, is the hydrogen actually bonding to that, or is it not? C double bond O, remember it's carbonyl group, C double bond OH. So the hydrogen bond to a carbon, it's not actually bonded to the oxygen. And then obviously with D, CH3, you've got a carboxylic acid, CH2, C double bond O, OH, and you know hydrogen bond to oxygen by the hydrogens, therefore it's going to be D. Which compound could not be produced by reacting 2-bromomethyl-3-methylbutane with sodium hydroxide? So with this, we can either go nucleophilic substitution or elimination, depending on the conditions, right? So we can, because the reactions are said to be competing. So 2-bromo-3-methylbutane, methane, ethane, propane, butane, methane, ethane, propane, butane, 2-bromo, Br 3 methyl. Now, if we undergo the elimination route, we will form, we can either form this where the double bond is here, or this where the double bond is here, and that's really it. So we can form, in this case, this is going to be what? That's obviously, that's a methyl group, so it's going to be three methyl butanene. Yes, so that can be formed. We can also have 2 methyl carbons, the methyl groups on the second carbon. No, 2 methyl butene, the carbon common bonds on the second carbon, and we also have a methyl group on the second carbon. 1, 2, yeah, double bond, and we've got butene. So that can be formed. And in this case, with NaOH, all we're doing here, placing the Br is nucleophilic substitution. That's all we're doing. So that's all that should happen. And what is that? That's 1, 2, 3 methyl butane 2-ol. So that can be produced. Therefore, the answer is A. And if you think about it, 2 methyl butanene, well then it should be here, right? Well, we can't have that. Question 23. The infrared spectrum of organic compound is shown. Which compound produces a spectrum? Look at the peaks. Obviously, the fingerprint region below 1500 centimeters to power -1. We don't care about that for this question. So, if we look at the peaks, we've got a peak here. We've also got a peak here. Those are 2 main peaks I can see. Now, the peak here is what? 1600, 1700, 1800, 1900, 2000, 1700. Peak here, 100, 200, 300, 400, around about something like that. So if we look at the table A, infrared absorption data, we've got a 1700 one. Well, it must be a C double bond O because that's between 1680 to 1750. So we've got C double bond O functional group, and we also have, that's what, that's like 100, 200, 300, 400, 2400. So that is going to be, it's not going to be a CH, it's going to be OH from an alcohol. OH, alcohols. So it's definitely not going to be ethanoic acid because that's got OH from a carboxylic acid. Propan 1-ol, that doesn't have a C double bond O bond. Prop 2-ene 1-ol, that also, it does not have a C double bond O bond. So the answer must be B, 4-hydroxy butanol. And that makes sense. It's got OH and it's got C double bond O. Question 24. The heat released when 1 gram of ethanol undergoes complete combustion. Is that was the heat released by each molecule? So we need to find out the moles of ethanol first, which is 1 divided by 46, which is 0.0217. And we are told that released 29,000. That released 29,800 joules. Therefore, 1 mole of ethanol, because we want to find out, because in order to find out the molecule, you need to find out the mole. So 1 mole of ethanol would be 29,800 in joules divided by the number of moles, 217. If we do that, we will get 13,70800 joules. And therefore, one molecule will release. All we have to do now is we divide it by Avogadro's constant. That's why they give us in the question. Divided by 6.022 times by 10 to the power 23. If I do that, I should get 2.78 times by 10 to the power minus 18 joules. So for the answer is A, and that is the end of multiple choice questions.